label that this is our point X and this is our point Y. Okay, so what we know is stress X is equal to minus 60 megapascal. We know that stress Y is equal to plus 90 megapascal. And then we know shear XY is equal to shear YX, and it's positive shear, so plus by 30 megapascal. Okay. So what are we trying to find out here? Okay, so there are a few things that we want to find. We want to find the first thing, principal stresses. So we know for principal stresses, the shear stress is equal to what? 0. Okay. We want to find the principal plane. Now this principal plane is critical for us. This principal plane is basically the optimum direction. Okay, optimum direction to lay the carbon fiber. Then we are going to find out the maximum in-plane shearing stress. So basically, this is the radius of the circle. And then we are going to sketch and label the orientation, orientation of the element along the principal plane. Okay. Now we are not going to use formulas. Okay, because using the formulas, you cannot visualize how this is related to your shaft. Okay, so we are going to construct Mohr circle. Okay, we're going to actually draw the circle. Okay, so now we are going to construct Mohr circle. Don't worry about writing. Okay, just sit down and listen. Okay, I will post this on Avenue. Okay, as promised as before. Right. So we are going to draw Mohr circle. So Mohr circle, we have an x-axis. Okay. So you have compression of minus 60. So I'm going to draw minus 80, 60, 40, 20, 0, 20, 40, 60, 80, 100. That is normal stress. So every 2 box is 20 megapascal. Okay, so on the y-axis is your shear. Right, your y-axis is your shear. So your shear also have to have the same scale with your normal stress. Okay, so element rotating clockwise, element rotating anti-clockwise, 20, 40, 60, 80. Okay, and then minus 20, minus 40, minus 60, minus 80. Make sure the scale are the same. If the scale are not the same, you will not get a Mohr circle. You get a Mohr oval. Okay, so you make sure the scale is the same. Okay, then you look at your first stress state is 60 megapascal. So 60 megapascal. So you have your 60 megapascal. your first stress state. Negative 60. All right. So this is your stress X line. And then your stress Y line is at 90. Okay, so you draw 90. Okay, so this is your stress Y line. The shear is 30. Okay, so the shear is 30. So again, the shear has nothing to do with positive or negative. It all depends on the rotation of the element. Okay. 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 So positive 30, negative 30. Right. Now we look at point X. Okay. We look at point X now. Okay. Point X is going to be on the minus 16 line. So this is our minus 16 line. Now, is it over here? Is it clockwise rotation of the element or anti-clockwise rotation of the element? So now if you were to focus on this arrow that I'm highlighting, right? So point X with that shear stress of 30 that highlight in yellow, the element will rotate clockwise or anti-clockwise. Anyone? Clockwise or anti-clockwise?
It's going to go counterclockwise.
Anti-clockwise, counterclockwise. Okay. So counterclockwise is on top or bottom? The top or bottom?
That's the bottom.
Yeah, bottom. So over here, this is your point X. Now you look at your point Y. Okay. Now point Y, highlighting in blue, right? So this is your stress Y line, right? So you also have a shear stress of 30. Now the 30 is inducing a rotation of a clockwise rotation. So it's on top. So this is your point Y. So once you have this, you can draw a straight line. So the straight line over here intersect a certain point where the shear stress is equal to 0. Over here where it touches, this is your point O. Okay, so to find point O is very simple math. Okay, it's really simple math. So now we want to find the center of circle. The center of circle is also known as our stress average. So this will be equal to stress X plus by stress Y divided by 2. Okay, so our stress X is minus 60 plus by 90 divided by 2. Remember, stress is a vector. Okay, you have to include the plus or the what? The minus. Okay, so minus 60 plus 90 divided by 2 is equal to 15. Positive 15 megapascal. Okay, so now we know where our center of our circle are. So it's our 15. Okay, and then the next thing is we can find the radius of our circle. Okay, now if you have a mathematical set, you can start drawing. You got your point X, you got point Y, right? You got center of the circle. You can use your compass. You can draw your circle, but this is digital. I don't have that. Okay, so I need to calculate the radius of circle. So this will be our tau max, right? So tau max is equal to what? Okay, so all you need to do now is to find this distance. Okay, so we want to find the distance from here to here. Okay, so this is what? So 90 minus by 15. So this is 75. Okay, so 20, 40, 60. Yep, 75. And then the vertical. Okay. Okay. So this will be our 30. Right? So to find the radius, so where is the radius of our circle? So what we are trying to find is this. So this is our R, which corresponds to our tau max later on, you see. Okay. So radius of the circle, very basic math, is equal to 75 squared plus by 30 squared. Okay. So 75 squared plus by 30 squared square root. So it's equal to 80.777. Okay. So from here, you can also identify your principal stress. Okay. So we can also identify our principal stress. Stress 1 and stress 2. So we can look for our principal stress. Sorry. We can look for our principal stress. Okay. Stress 1 or 2. So this is equal to stress average plus or minus your tau max. Okay. So this will be equal to positive 15. Oi. So this will be equal to positive 15 plus or minus 80.777. Okay. So 15 plus by 80.777 is equal to 98.777 megapascal. And the other one is plus 15 minus 80.777 is equal to minus 65.777.
Wait, 98 or 95?
Wait, 15 plus 80.777, 95. Thank you so much. What's your name?
Griffin?
1 pint of beer. Okay. 95.777. Okay. So now you know your principal stresses. Okay. Now you can construct your circle. So 65, I'm just going to eyeball this. And then 95, 90, 95, I'm going to eyeball this. And then the tau max is 80 point something. There you go. So there's your Mohr circle now. So where are we? Okay. So we have found our principal stress. Okay. We have found our maximum in plane shear stress. Okay, which is equal to 80.777. Okay, and we have found our principal stress. Okay, so we are halfway done. Okay, right. So from here, okay, so the next thing is we want to find, we already know what is stress 1 and stress 2. So over here, this is your stress 1. Okay, and over here, this is your stress 2. Okay, we found our stress. So now we want to know what is the angle. Okay, what is the angle to reach to reach where the shear stress is equal to 0, and we're going to call this angle 2 theta p. Okay, we're going to call it 2 theta p. Okay, and I'll tell you why 2 theta p later on. Okay, so to find 2 theta p, okay, so this is equal to inverse tangent 30 divided by 75. Okay, and then theta p is equal to 30 divided by 75. Inverse tangent divided by 2 is 10.9 degrees.